Agrawal, a second-year master's student at CSRC. My research is to develop graph convolutional network-based dynamic task scheduling for mobile ad hoc computing. In recent years, we have witnessed the significant growth of mobile applications that are based on advanced artificial intelligence and deep learning models, such as face recognition, object recognition, and natural language processing. These applications stimulate the demand for greater computing resources, which may be difficult to support in one device or vehicle. Therefore, mobile ad hoc computing is a promising solution to address this need, which provide local computing services by enabling resource sharing among mobile devices. Example of mobile devices include unarmed aerial vehicle, ground vehicle, robot, smartphone, tablet, etc. Task scheduling is a key challenge encountered in this system because it aims to figure out the optimal schedule for the list of tasks which needs to be executed on this computing nodes in this system. Effective task scheduling helps us to maximize the use of computing resources and shorten the time needed to complete tasks. As you can see in the diagram, we have number of tasks which needs to be executed on number of processors. But we need to decide which tasks need to be executed at what time. That is, we need to decide the task priority in order to have optimal schedule, which can be done with the help of a scheduling algorithm. Existing study shows that there are a number of heuristics that have been previously proposed to optimize task scheduling, such as HEFT algorithm, random scheduling algorithm. HEFT scheduling algorithm, that is heuristic earliest finish time algorithm. In this algorithm, we decide the task priority on the basis of upward ranking. Upward ranking is calculated on the basis of computational cost, that is the cost of every task on every processor, and communication cost, that is the communication cost between the task, that is inter-task dependency. As you can see in the diagram, after task 1, we are free to execute task 2, 3, 4, and 5. But we need to decide which among these tasks should be executed first. Therefore, in HEFT algorithm, this is done by using upward rank, whereas in random scheduling algorithm, this is done by selecting the task randomly. That is, after task 1, we randomly select among task 2, 3, and 4. At the end, after finishing the task graph, we generate a overall schedule in both of the scheduling algorithm, which gives us the optimized schedule. Despite being the benchmark algorithm, this algorithm has some limitation. That is, this approaches mostly consider system to be static and are not scalable. That is, they tend to fail when there are complex data sets. That is, they tend to be very slow or fail with complex graph. Secondly, we all know that robot can move, which may cause frequent topological changes, packet loss, and time-varying communication delays. Thus, this need to be addressed. Therefore, the objective of our study is to develop a scalable and dynamic task scheduling algorithm for mobile ad hoc computing system formed by mobile compute nodes. Therefore, in our study, we have tried to leverage the graph convolution network to solve the scalability issue. Since it is a machine learning algorithm, it can quickly schedule tasks by carefully integrating a task graph with network setting into a single input graph and feeding it to our GCN model. Secondly, in order to solve communication delay constraint, we have introduced a dynamic scheduling update rule, which will address our communication delay. In this, we are introducing a time frame. In this time frame, we will generate only those tasks which can be scheduled. And then after scheduling this task, we will, in the next time frame, we will schedule the remaining task, and so on. At the end, we will have our overall schedule. The future work which needs to be done is to implement the dynamic schedule rule in GCN scheduler and implement the proposed GCN schedule on ground robot and evaluate its performance. Our acknowledgements are as follows. Thank you.